Okay, in this video we're gonna talk about complex numbers, their early or elementary definitions, and their properties. We're just gonna do a brief introduction with some easy to learn examples. After that, we're gonna start proving every property that we deal with. And so we define the set of complex numbers as C. So C, the set of complex numbers, it's denoted this way. It's the set of those numbers that can be written as a plus ib with I squared is -1 and ab reals. Okay, so this is a set of complex numbers. In general, any number that belongs to this set can be written in this form. Okay, so for instance, if we have z as a plus ib with a and b in R, let's call it z1, and z2, let's call this one a1 plus I b1, and z2 is a2 plus I b2. Okay, so now we have two complex numbers. The a1, b1, a2, and b2 are real numbers. Okay, they have to be real. For instance, we can say that we can take an example. For instance, call it z is 1 plus I. So in this case, this is a real a complex number with a as 1 and b as 1. Okay, so this is a complex number. Why? Because it's written at this form here. Okay, so because written at this form. So that's one example. Sometimes we have z is 2. So this is a complex number. It's a real complex, but it doesn't have this part that comes with the I. In this case, we say that the imaginary part is 0. Okay, so it's like 2 plus I times 0, which is 2. Okay, sometimes we can have only the imaginary part, let's say 5i. So this is a complex number, but it has only the imaginary part. So the a's and b's, the a is called the real part, the b is called the imaginary part. So in this case, this number is called pure imaginary because it doesn't have this part that we call real. Sometimes we need to do some notations. Let's say real of z is a, and I am for the imaginary of z is b. Okay, these are notations that we're gonna need later when we have to prove more stuff. So in this case, when we're given these numbers in general, so for now we just forgot this notation here. Okay, so you're gonna deal with it when you go to advanced mathematics, but for now let's just focus on the addition, division, multiplication, and scalar multiplication. What do I mean by scalar multiplication? So for instance, you have this z is 1 plus I. So what's 3z? 3z is just you multiply and you distribute. So it's 3 plus 3i. Okay? But first, the early operation that we need to define is addition. So what's z1 plus z2? So in this case, we're adding two complex numbers. Okay? What we do is we add the real part with the real part and the imaginary part with the imaginary part, and we put them together without forgetting the i's that comes before the imaginary part. So here we have a1 plus a2, okay, plus I b1 plus b2. So this is the addition. So to add two complex numbers, just add the real part together, add the imaginary part, and put them together without forgetting the I that satisfy this condition here. I squared is -1. another operation that we defined is, let's say we want to do lambda sub z1. So we multiply this z1 by any lambda that belongs to R, that's real number. So what we do is you multiply each of the imaginary part and the real part, the real part and the imaginary part by lambda. So what we do is lambda a1 plus I b1 is lambda a1 plus I lambda b1. So they make it easy to learn. I put the lambda after the I. Okay, this lambda is real, so this is our notation. It's real number. We can do imaginary part as well, knowing that we can do let's say we have let's say our z can be like z is 2 plus I. Okay, so what's 2iz? 2iz is 2I times 2 plus I. So when doing this operation, we work as like in R, but we take into consideration this fact that I squared is minus 1. So here we have 2I times 2 is 4I, but 2I times I is 2I squared, which is minus 2. So we have minus 2 plus 4I. Okay. Another operation that we can define is the multiplication, z1 times z2. So this one we need to do some work. Okay, so we're gonna do a1 plus I b1 times a2 plus I b2. Okay, so we distribute, but we take care of the fact that I squared is minus 1. So we have a1 a2 plus I a1 b2 plus I b1 a2. I times I is minus 1, so minus b1 b2. Okay, now the operation here, the minus comes from the fact that I times I is minus 1. So we take the real part, a1 a2 minus b1 b2. Okay, and we add this part here, it's a1 b2 plus b1 a2. Okay, so we need to we distribute, and we take take the real part, we collect the real parts with the real part and the imaginary part with the imaginary part. This is how we get this expression for the product. Okay, so it's good to practice. So when you are learning this one for the first time, it's good to do this operation by yourself. Okay, another one is that if we have z is, let's say a plus ib, and we want to compute 1 over z. So 1 over z is, it's 1 over a plus ib. So you multiply the top and the bottom by a minus ib over a plus ib times a minus ib. This is the conjugate. So this number here, so let's define this one as well. So if we're given that z is a plus ib, z bar, which is a minus ib, is called the conjugate of z. Okay, so this is the notation for that. So here we multiply by the conjugate. Okay, so in this case what we get is that we get a over a squared plus b squared minus I b over a squared plus b squared. Okay, we're gonna prove all these ones in another video. So because here we get into some computation that someone might have never seen. Okay, so this is the case here for us. So when you flip this one, you multiply by the conjugate, and you do the operation here. You do the multiplication rules, and you collect the real part with the real part and the imaginary part with the imaginary part. Okay, so but this is just an introduction for complex numbers. We will see more and we're going to prove more results in the coming sections.